Section 3.2, guys, we're talking about polynomial functions. Can you guys see my screen at home? Okay, so we're talking about polynomial functions. Guys, poly means many. It means an equation that has many terms, all right? There's all sorts of different things that we talk about when we talk about polynomials. The leading coefficient. Leading means it's in the front. Coefficient means a number in front of a variable. So in this case, 3 would be our leading coefficient. So you might have a test question that says, name all of these things, the leading coefficient, the degree, the constant term, that sort of thing. The leading coefficient is the number in front of the exponent, or the variable that has the highest exponent. All right, when you talk about degree, look at the degree. The degree of a polynomial is whatever the highest exponent is. All right, it's the highest exponent. You should write your equation in standard form, meaning from the biggest degree to the smallest, but your degree is always the highest exponent. A constant, guys, look, your constant is back here at the end. It's the term that doesn't have a variable. Your constant has no variable with it. All right? If I ask you what the leading term is, that would be this whole entire thing of 3x to the fifth. So there's two different things. The leading coefficient is just the number that's in the front. The leading term is the entire thing itself, meaning the number, the coefficient, and the exponent. And then if you had to state all the coefficients, it's all of the numbers in front of the variables. In this case, -6 is a leading coefficient because this is the same thing as x to the 0 power. If you guys notice, when we talk about terms or leading coefficients, the sign that is in front of the number goes with it. So 3 is positive, 6 is positive, 2 is negative, that sort of thing. Does anybody have any questions about that? All right, you guys have seen it before. Okay, here's just a table kind of listing the same things. If you notice, when we talk about degree, I told you degree is the highest exponent. Highest exponent. All right, the leading term is the entire term that's in the front, the number and the coefficient. The leading coefficient would just be 4 in this case. The leading coefficient here would be 1, but the leading term is x squared. It's everything to it. Do you see how this is the 4th degree because the highest exponent is 4? The leading coefficient here is -5. The leading term is -5x to the 4th. Anything that we talk about a constant is the number at the end that doesn't have a variable. So the constant here is -7. The constant here is 10. The constant here is -2. What's the constant here in the second example? What are we adding or subtracting there at the end? 0. So your constant would be 0 or none. You can see either one. All right, when we talk about functions, guys, all right, we're going to talk about a bunch of different functions. Every time you have a function, there is a graph that goes with it. Every single function family has a different picture. This is x to the first. This is x to the second, or x squared. Do you notice the difference in the shape of the graph? X to the first is a line, x squared is a parabola, it's a quadratic. The higher the exponent, the more bumps that your graph will have. So if I have something that's to the 3rd power, do you see I have a bump? It'll go, I got a bump like here and one here. The 4th power actually has 2 little bumps, here and here. It's actually got 3. To the 5th power, it's going to bump a little more. But what do you notice? Look at the ends of the graphs here. What do you notice about the ends of the first graph and the last graph? What are the ends doing? They're going in opposite directions. Opposite directions. The arrows are going in opposite directions. Okay, what do you notice about the exponent in each of these graphs?
They're odd.
They're odd. So what do you think is going to happen at the end of any graph that has the leading x, or the highest degree, the biggest exponent, is odd? What's going to happen to the direction of the arrows? They're going to go in opposite directions. What do you notice about the arrows here? They're in the same direction. What do you notice about this exponent? It's even. You guys remember that from anything we just talked about and behaviors? We haven't talked about end behaviors yet, but we've talked about odd, even, and either graphs, right? An odd function, the arrows go in opposite directions. An even function, the arrows go in the same direction. So we're going to talk now about end behaviors of a graph. What's going on at the end of a graph? And you can tell me that just by looking at the equation. So we're going to walk through some. All right, it says, however, as the degree n becomes larger, the graph becomes flatter. All right, not really that big of a deal that you guys understand that. But if I was going to sketch the graph of the following functions, all right, let's talk about, we're not going to graph anything on the test, but let's just talk about what this graph would look like. First of all, what does that negative sign out in front mean? It's going to flip, it's going to reflect, okay? That's a reflection over the x-axis. And since this highest exponent I have is a 3, what's going on at the end of my graph, the end behaviors? Are the arrows going in the same direction or opposite direction? Okay, we'll say opposite direction. We'll get a little more specific in a little bit, but you can tell that by looking at the equation. If I look at this next one, you can tell me right now, end behaviors. What's going on at the end of the graph? What are the arrows doing? They're going in the same direction. Where does this graph, whatever it looks like, where does it move? To the right, too. Very good, Nico. Good. All right, when I talk about this last one, what's the highest exponent you see? 5. What kind of a number is 5? It's odd. So the end behavior of this graph, what are my arrows doing? They're going in the same direction or opposite directions? Opposite directions. Good. What does this minus sign right there mean? It's a reflection over x. What does that 2 mean? The vertical what? Stretch. Good. What does that plus 4 at the end mean? It's going to go up 4. It's not in parentheses or anything like that, so it's going to go up 4. But you guys you can tell all sorts of different transformations and stuff just by looking at the equation itself. Questions? Whoops. Anybody have any questions? Okay. Moving along. When they talk about a graph being continuous, what does it mean if something is continuous? It goes on forever. It doesn't stop. Is this graph continuous? No, because it has a stopping point, a breaking point, if there's a hole in the graph. A continuous graph doesn't have any stopping or starting. It just goes from one side to the other with no stopping or starting. That's all that means to be continuous. All right. Is this graph continuous, not continuous? We're going to look at some of this stuff. If you have any sharp or cusp things, this is not continuous, not a function. Do I have any issues here? Nice and smooth, we're good to go, no problems here. What about this one? Nice and smooth, good to go, so that is a function. This one is not a function because it has sharp peaks or something they call a cusp. We'll talk about this in a second. All right, this is called arrow notation. All right, we're going to talk about end behaviors in 2 ways. We're going to talk about arrow notation, and we're going to talk about what's happening on the left and the right. So once we talk about what happens on the left and right, then we can talk about this arrow notation. What this says is as y approaches infinity, x approaches infinity. I always write it with x first. If I look at the x-axis, guys, this is negative infinity, right? This is positive infinity. So if you were to say, as x approaches negative infinity, what that's saying is look on the left-hand side of the graph. What is your y value doing? Is it going up or down? So then you would say f of x or y, however you want to write it, goes one direction. Then we'll talk about as x approaches positive infinity. That's the right-hand side of the graph. You would tell me f of x or y does what? Okay. This is going to make a ton more sense in 2 seconds when we go over some examples. This is just a fancy way of writing the end behaviors. If I look at, I don't even want to talk about it. Well, yeah, we can talk about this. Okay? If you have a function, what do you notice about the arrows of this function? These two. What do you notice about the arrows? They're opposites. So that means it's an odd function. If I asked you what the end behaviors were, the first thing that I would want you to say is look at the left-hand side of the graph. Is the left-hand side of the graph, look where the arrow is going. Is it falling or is it rising? Is it going downwards or is it going upwards? It's going down. So you would say for this, the end behavior is falling on the left-hand side. So falling left. Look at this graph on the right-hand side. Which way is it going? So it's rising on the right. We'll talk about how to write that in end behavior notation in a second. Look at this graph. You always start on the left-hand side. We read from left to right. What's it doing on the left-hand side? Is it rising or falling? It's rising on the left and doing what on the right? Falling on the right. When you have an odd function, you have to think a little bit. When you have an even function, you don't have to think that much. Because an even function, you know the direction of the arrows are going the same way. So what's going on here in this even function? It's rising on the left and what? And rising on the right. Good. So to write this, falling left, rising right, as x approaches negative infinity, f of x, that means y is doing what? Look at guys. And when I look on the left-hand side of the graph, which infinity is y getting closer to? Negative or positive? Think on the y-axis. What infinity is down here? Negative infinity. Whoops, not negative 8. So as x approaches positive infinity, that means the right side of the graph. F of x, or y, is doing what? Is it going towards positive infinity, or is it going downwards towards negative infinity? Is it going to positive infinity, or is it going to negative infinity? It's going to positive infinity. So when you write rising left, falling right, this is exactly what you're saying. This part will always stay exactly the same. When you talk about end behaviors, that will always be the same. The only thing that's going to change is this last little bit right there. This is not anything math computation-wise where you guys are working anything out. You have to pay attention to what you're doing in for a second. So, determine the end behavior of this graph. Do we have a picture? You guys have a picture to look at? Does anyone see a picture of a graph?
I only see
the equation, right?
Yeah.
Okay. You can tell the end behaviors just by looking at the equation. The first thing you're going to do, look at the exponent. The highest exponent I see is what kind of a number? Even. Okay, so let's think about this. It's even. When I think of the word even, what do I think about the directions of the arrows? Same or different? Same or opposite, I should say. I'm sorry. They're the same. Okay, so there's two choices. They're either both going upwards, or they both could be going which way? Down. This tells us the answer. Which way are both of these going? Which way are both of the arrows going? What does that say right there? What sign's in front of the two? Negative. So since it's negative, that means they're both going downward. So you would tell me it's falling on the left and what? Falling on the right. So as end behaviors go, you guys are going to have to write end behavior notation. Every single time you write the same thing. As x approaches negative infinity, f of x approaches something. And as x approaches positive infinity, f of x approaches something. So think about this. On the left-hand side of the graph, right? Here's my graph. The left-hand side, the arrow is going down. What infinity on the y-axis is down here? Negative infinity. On the right-hand side, the arrow is going in which direction? Down. Which infinity on the y-axis is down? Negative infinity. So there's your answer for your end behaviors. You look at the highest exponent, and then you think about what the graph would look like in your mind. It's always easier when it's a even exponent, because they're either both going up or they're both going down. When it's an odd exponent, you got to think a little bit more. Questions? We're going to work on a bunch of these. All right. Using zeros to graph polynomials. It says C is a zero of P, X equals C is a solution. You know what this means to do? You're going to factor. When we find what X equals, we're finding X intercepts. That's where the graph crosses the X-axis, right? We can also call those roots. We can also call them solutions. We can also call them zeros. Those 4 words all mean the same thing. They mean factor the equation and tell me what X equals. This is not new. So when I go to here, let's just look at this problem right here. It says find the zeros, okay? If I'm going to find the zeros, it says P of X equals X squared plus X minus 6. Guys, when you find the zeros, what do you do? How do you find it? To find the zeros, what do? We plug in 0. We're going to factor. So I have X squared plus X minus 6 equals 0. So what 2 numbers multiply to give me negative 6, but add to give me 1? X plus 3, X minus 2. So my 2 zeros, my 2 X intercepts, my 2 solutions are X equals negative 3 and X equals positive 2, right? Those are where the graph is going to cross the X-axis. Now think about the end behavior of this graph. What's the highest exponent you see? 2. What kind of a number is 2? Even. When I think even, what do I think about the arrows? They're both the same. And then I look in the front. Is that a positive X squared or negative X squared? Positive. That means both of the arrows are going in which direction? Up. So you would tell me that it's rising on the left and rising on the right. All right, when we say rising, that's positive infinity. When you say falling, that's negative infinity. So to write it as end behavior notation, as X approaches negative infinity, f of X does what? It approaches, boom. On your test, I'll have all that written out. You just have to fill in the boxes. So as X approaches positive infinity on the right-hand side of the graph, what's Y doing? In this case, if they're both rising, which infinity are they going to? Positive infinity or negative infinity? Which infinity is up here on the y-axis? So they're both going to positive infinity. So when they are asked to find the zeros, all that means is factor. And then when we talk about the end behaviors, you have to figure out what the end of the graph looks like. You don't need a picture. You can find all of that just by your equation. I'm not super worried about that. All right. This says find the zeros, sketch the graph. Okay, this is the last one we're going to do. Well, maybe not. Find the zeros, sketch the graph. So the first thing I'm going to do is the zeros. Same as x-intercepts. Same as solutions. Same as what? Roots. So I'm going to say x cubed minus 2x squared minus 3x equals 0. When we factor, what's the first thing we look for? Is there a GCF? Yeah. Okay, I can take out an x, and I'm left with x squared minus 2x minus 3 equals 0. Can I factor that more? Yeah. Okay. What times what gives you -3 when you multiply and a -2 when you add? X minus 3 and x plus 1, agreed. So I have 3 x-intercepts here. I have 3 zeros at x equals 0. I have 1 at 3, and I have 1 at -1. Questions? Anybody have a question? Everybody at home, you're so good to go. This is so easy and this is awesome. Fantastic. Why don't I believe that? All right, let's look at the highest exponent that we see in our equation. What is the highest exponent you see? 3. What kind of a number is 3? It's odd. So when I think odd, what do I think of? Opposite. Okay, now here is the way that you guys figure out end behaviors if the function is opposite. I want you to think about a line. Right? You guys agree with me that a line is an odd function? Okay. So if I have a positive line, would you guys agree with me? A positive line goes like that, right? And a negative one does what? Goes the opposite way. So what am I looking at here? Is this positive x cubed or is it negative x cubed? It's positive. So my graph is going to look something like this line. It's going to have some more bumps in it. But what's going on the left-hand side of an odd function that's positive? It's going which way? Which way is the arrow pointing? So it's falling down. So it's falling on the left-hand side. And what's the arrow doing over here? Is it going up or down? It's rising on the right. So think about this. When I'm talking about infinities, on the y-axis, if something is falling, is it going to negative infinity or positive infinity? If it's falling, is it going down to negative infinity or is it going up to positive infinity? It's going down on this side. And what's it doing on the other side? Going up. So when I write out as x approaches negative infinity, that's the left-hand side of the graph. What's y doing? It's going to negative infinity. As x approaches positive infinity, that's the right-hand side of the graph. This is the left, this is the right. What's your y value doing? It's going to positive infinity. The concept of this, guys, really and truly is on the left-hand side, what's the graph doing? Going up or down? On the right-hand side, what's the graph doing? Going up or down? The concept is not crazy hard. This is weird. Like, this is new. But like I said, it's not, it's just like a different language. I know some of you are looking at it like it's a total foreign language, and I get that. But everybody in here is totally capable of figuring this out, 100%. Oh shoot, we get out here at 55? Oh, I thought it was 12:05. Okay, my bad. Okay, let's scoot along. What does this say? Multiplicity. This is a concept that's easy. How many kids do I have? You better answer this question. Kennedy, Hannah, how many kids do I have? 2. Oh, no. No, just 2. And did I have them at the same time? Mm-hmm. They're called multiples. All right? I have multiples. Multiplicity is when you have the same x answer more than one time. So if I was going to find the zeros here, I would just set this equal to 0. So I would say x to the 4th equals 0, x minus 2 cubed equals 0, and x plus 1 squared equals 0. So when I solve this, I get x equals 0. What's my multiplicity? How many times do I have x equals 0? 4 times. You'd have a multiplicity of 4. In this case, I'm going to solve this and I get x equals 2. What's the multiplicity? I'd have a multiplicity of 3. Over here, x equals negative 1. What's my multiplicity? Yep. This is like a vocabulary lesson. So if I gave you guys this and I said to you, and we'll do this tomorrow, I'll do a couple examples. I'll just make up a couple examples. We'll talk about end behaviors, multiplicity, all that stuff, and then I'll give you the web sign. But if I said f of x equals x squared, hold on, I gotta think for a second, plus 6x plus 9, and I said find the zeros and state the multiplicity if there is any. How do you find the zeros? How do we find zeros?
You set it to 0.
Perfect. Set it equal to 0. We're going to factor. So now I'm going to factor this. What times what gives me a positive 9 when I multiply, but a positive 6 when I add? X plus 3 and x plus 3. Do I have multiplicity, guys? Do I have the same answer twice? Yes. So here you would tell me my answer is x equals negative 3, and I'd have a multiplicity of what? Yep. I can't even spell it. Multiplicity of 2. It's like twins. What's the end behavior of this graph? Real quick. Okay. Look at the number is even. The highest. So then even means same. So that means they're either both going up or they're both going down. Which way are these ones going? Both going up. It's rising on the left because x squared is positive, and it's rising on the right. Good. This is not hard. We're going to go over this more tomorrow, I promise. So then I'm going to write out my fancy. Well, as x approaches negative infinity, that's the left-hand side of the graph, f of x approaches what? What is y doing? If it's rising, which way is it going? To which infinity? Positive. Good, Nico. So then on the right-hand side, I'm going to say, okay, as x approaches positive infinity, f of x is going, if it's rising, it's going to which infinity? Positive. Good. So tomorrow when you come in, the first thing I'm going to do is I'm going to have a bunch of, probably 5 of these. We'll talk about zeros, end behaviors, all that stuff. And then I will let you guys start your web assign, and it'll be due Thursday morning. Sound good?